Welcome everyone, this is ThalesNano webinar about catalyst cartridges, so-called CatCarts. The outline of this webinar will look like this. First, I like to introduce our company, then we will jump right into the object and start to talk about CatCarts, what are CatCarts, how they are built up. I give some scale up and scale down options, and then we will have a question and answer session. So, what happened before? The summary of the webinar series includes a webinar about the HQ Mini Plus, the HQ Pro, and our newest instrument, the PhotoCube. You can check these on our website. About ThalesNano. ThalesNano established in 2002 and we are on the market since then, and we are the market leader in this flow chemistry market. We have more than 1,400 sold instruments over 6 continents, and we have more than 700 publications and 2 R&D Top 100 awards from the USA. Let's talk about CatCarts. CatCart is an abbreviation from catalyst cartridge words. These are basically a stainless steel tubes where heterogeneous catalysts are isolated inside with a sealing system. There are several types of CatCarts. We have the so-called H-Cube type CatCarts, which we are selling in 2 different sizes, 30 by 4 and 70 by 4 millimeters. We have a scale down option for these cartridges, the so-called micro CatCart or microcart, and the scale up option for H-Cube MIDI reactors, so-called MIDI cart. And of course we have a customizable cartridge for Phoenix flow reactor, which we call metal sealed cartridges, or shortly MMS cartridges. Alright, let's talk about first the H-Cube CatCarts, how they built up. First, these are stainless steel tubes and the catalysts are sealed inside with the following sealing systems. These systems are the same at both sides, so basically everything I say now are at both sides. First, there is an end-closing polytetrafluoroethylene ring. Why this? Because this is temperature resistant, pressure resistant. We can close it with high pressure and it deforms well inside the closing area, and it is a completely enough material for all of the materials we will use during our reactions. Next comes an 8 micron pore size stainless steel filter. It has a high flow-through capacity and it gives mechanical stability to the next part, 1.2 micron pore size PTFE membrane. This is an inert membrane and this is our particle size barrier, so 1.2 micron is the smallest particle it can contain inside the sealed area. Then the closing the catalyst loading comes. These are all the times heterogeneous type catalysts with various supports, various transition metals, and a wide range of chemical reactions because of this flexibility. Let's talk about the catalyst loadings. We are using several supports, as in the chemistry industry everyone does. Let's talk about the carbon types first. We have several transition metals on carbon, and also we have different sizes of these carbon loadings. Alumina is also a good choice for catalyst because it can go up to the temperature and it can hold several transition metals at the surface. Zeolites are not so common as a catalyst carrier in chemistry.
So we also doesn't have too much of these, but at the picture it shows a silver exchange zeolite, so we also sell these. Silica is also a very good support for heterogeneous catalysts because it's temperature and pressure resistance, but its surface is not so absorbent as alumina or charcoal, but we also sell different types of these. And of course, polymer bound catalysts we are also selling. The drawback of this catalyst is that the temperature maximum for this catalyst is 120 degrees Celsius because the catalyst support the more the time divinyl benzene can melt and deform the catalyst and causing clog after a while. So what we can play with the catalyst loading? First of all, of course, the transition metals and the support, but when you found your perfect support material and the right catalyst, transition metal to that support, you can also play with the particle size of the heterogeneous catalyst. The bigger the particle size, the bigger the void volume inside the cartridge, so the residence time will be higher at that cartridge, but also you have a less contact surface volume area. When you are choosing a small particle size catalyst, it's a double edge blade because you also have a high surface volume area, but also probably you will face with a higher pressure drop on the catalyst. Alright, our scale-up options for the CatCarts. Firstly, the MIDI cart. MIDI carts are made for H-cube MIDI reactor, but also can used in Phoenix Flow reactor combined with H-cube Pro or just in standalone mode. The difference between the H-cube type cartridges and MIDI cart that this is much bigger. The inner volume of the MIDI cart is 10 times bigger than the bigger H-cube type cartridge, the 70 by 4 millimeter cartridge. So the whole body is made of stainless steel again, but here we have stainless steel frit as a closing part and also 6 separators which are separating the catalyst area into 5 zones. These are for a better mixing and to prevent the tunneling effect when you are running the reaction with higher flow rates. These are made for bigger scale productions, nominally 10 to 500 gram per day production. And because of the dimensions of the tubes are very correlated with the H-cube type cartridge, you can easily scale up the reaction from the H-cube reactions to the H-cube MIDI cartridge. The catalyst inside is also a little bit different than the H-cube type. While the H-cube type cartridge contains 20 to 100 micron particle size catalyst, sorry. The H-cube MIDI contains 100 to 800 micrometer particle size catalyst. Okay, after we saw the scale-up options, let's go to the scale-down options. For very small amount of starting materials and very sensitive reactions, we made a very small inner volume cartridge, so-called microcart or micro CatCart. This is basically a modified 30 by 4 millimeter cartridge. We put 2 PTFE spacers inside and only using 1/3 of the inner volume of the 30 by 4 millimeter cartridge. Because the outer dimensions are the same and sealing is the same, So you can use the micro CatCart into H-Cube Mini Plus, H-Cube Pro, X-Cubes and all the other instruments where you can use the normal H-Cube tire cartridge. Now we can go into a little bit different area. After we introduced our Phoenix flow reactor into the market, and it was capable of go up to 450 degrees Celsius, we had to figure out how to solve the cartridge issues at this high temperature. And the solution was the metal sealed columns, metal sealed cartridges. These are all stainless steel build-ups, no PTFE, no rubber or any other materials present in the cartridge. So the user can go up to 450 degrees C with these cartridges when the catalyst support let this. These are made for Phoenix flow reactor and because of the unique design, these are completely refillable. So, apart from the other CatCarts, metal-seal cartridges can open by a user and fill with their own catalyst and use with that. We have two commercial lengths for these cartridges, 125 millimeter and 250 millimeter long. These are actually the half and the full length of the Phoenix flow reactor. And also we have different width of the cartridges, 1/8 outer diameter to 1 inch outer diameter cartridges. So you can go with a very small cartridge and you can scale up to a very big reaction scale with only one instrument but different cartridges. Our top-selling catalysts are basically the palladium, platinum, rhodium, ruthenium and nickel family cartridges catalysts. Palladium on charcoal is our number 1, rainy nickel is our number 2 and platinum on charcoal is our number 3. We are selling individually these catalysts, but also we have kits we are selling to our instruments which are selected catalysts for specific or just a general purpose of reaction and flow chemistry. Let's talk about our latest CatCart. Is SiliaCat DPP Palladium, is a silica based complex palladium catalyst. Basically it's made for coupling reactions and we made in-house a Suzuki Miura coupling with this catalyst, but also because of the unique features, alkoxy carbonylation is also a usable reaction for this catalyst. Okay, I like to talk about a few frequently asked questions about CatCarts. The first of all, what is the production capacity of a CatCart? First of all, it depends on many aspects. The catalyst type, the catalyst mass, the cartridge size, and the reaction parameters, and the reaction starting materials purity, etc., etc. But basically, with a micro CatCart which contains 30 mg filled catalyst, you can go for microgram scale reactions. For the 30 by 4 mm cartridge, the catalyst filling varies from 100 to 500 milligrams. It's catalyst dependent, and also the capacity varies from a few hundred or 100 milligrams to a few grams. With a 70 by 4 mm CatCart, the filling catalyst mass varies from 300 to 1500 milligram, and the capacity also varies from a few hundred milligrams to even dozens of grams. With a MIDI cart is a little bit different. The catalyst filling varies from 1 gram to even 15 grams, and the capacity can go up to 500 grams per day.
with metal sealed cartridge, because they are very variable, also the productivity can vary with the size and the cartridge. How you can elevate the production scale or capacity on a CatCart? First, you can choose the instrument right. When you're using like HQ Mini or HQ Pro or any other hydrogenation instrument, you can consider the hydrogen amount of the instrument can produce. And also you can choose the right column type, a small or a longer ones, to correlate with your reaction scale. The concentration and the solvent the users use also have a very deep effect on the production. First, the solvent's protic behavior is very important when you are using palladium and platinum type of catalysts. And with the solvent, you can play with the maximum achievable concentration with the starting material. The catalyst type is of course important. You can vary the transition metal type, the transition metal amount on the cartridge, and also the support, which are important because there are neutral, acidic or basic supports which can have a different effect on the reaction. I already talked about chemical purity, but it's very important because even a few percent can have a very severe impact on the outcome of the reaction. First, the impurities of the starting materials are very important, and also the dry or wet solvent differences are also seeable during the reaction. The next slide is about the reactivation. We get more and more questions about reactivating CatCart. And of course it's possible, but not in every cases. It's very strong, it has very strong link with productivity, but of course not every catalyst and not every occasion can be done this reactivation. I can only speak from my experience. In case of palladium on charcoal and rainy nickel, running the catalyst through with methanol at high temperature and pressure by using hydrogen can liberate the active spots and reactivate the catalyst after a few minutes. In the case of palladium hydroxide on charcoal, it doesn't work because of the catalyst working method is very different. During the reaction, the palladium hydroxide reduces and produces nano palladium zero particles, and you cannot turn these back. So first we can talk about poisoning the catalyst or inhibition of the catalyst. Inhibition is a very weak link between the inhibitor and the catalyst material, so it can be turned back and you can liberate the active spots. While we are talking about poisoning, it's also a permanent thing, like in the palladium or platinum transition metals, any lead, sulfur or like these poisoning materials can be removed from the surface. Okay, let's talk about how to start with a CatCart. First of all, every cartridge is made for only one placing into the instrument. So the sealing is worked through a deformation. So while the instrument is sealed with the cartridge, the PTFE closing rings deform, and there is no guarantee the user can do this the second time to put the catalyst exactly the same way as in the first time. When you start with a brand new fresh CatCart, you have to consider pre-activation and washing of the catalyst. These catalysts are usually wetted to prevent pyroforic accidents while
using these catalysts. When your reaction is water sensitive, you have to wash carefully these catalysts through a water miscible solvent, dry solvent of course. Some catalysts are stored even underwater, like rainy type materials, because they are so active that when they dry up, they catch on fire. Pre-activation is also a good method to enhance the catalyst activity, like in the case of rain and nickel, for example. You can wash the catalyst with water at high temperature pressure with hydrogen, and then change to a water miscible solvent. This is how you can elevate the catalyst activity even before the first run. When you using a brand new catalyst and place it into the cube or Phoenix flow reactor, you set the reaction parameters and hit the start button. After you reach stable state, it's recommended to wait at least 5 minutes before starting the starting material addition into the liquid line, because the catalyst can act weird at the first run. So after the stable state, it's advised to wait at least 5 minutes to be sure that the instrument parameters are really in stable state. What type of reactions can be done on CatCart? First of all, HQs originally made for hydrogenation reactions. And because of these, the majority of catalysts we are filling inside the cartridges are fulfilling this purpose. For example, palladium, platinum, ruthenium, rhodium, and other catalysts from 0.5 to 20% transition metal amount are available in our portfolio. And these are basically for hydrogenation reactions. But of course, with flow chemistry, you can do variety of other chemistries. For example, cross-coupling reactions. For these, we recommend palladium complex polymer bound catalyst on silicon support, divinylbenzene, or Johnson Matthey's very special line, the FiberCat series. These are made for cross-coupling reactions and other sophisticated reactions, but not for hydrogenation. Also, you can do ring closing and opening reactions with flow chemistry, with playing with the temperature, the starting materials and the pressure, and you can even do this on an inert cartridge, or zeolites or montmorillonites. Of course, connecting a gas module to the cubes, you can do different gas type reactions than hydrogenation. For example, oxidation with gold catalyst, Fischer-Tropsch reactions on iron containing catalyst, and of course carbonylation with carbon monoxide. How many CatCarts are available? At the moment, we are selling more than 100 type of CatCarts with 11 different transition metals as an active particle. Our latest catalysts are not containing any transition metals. These are montmorillonite K10 and K5 cartridges. These are for precursor, ionic liquid precursor formations. We continuously try to find and explore new catalyst types and chemistries to fulfill our users' needs and questions. And of course, during the catalyst development, we are facing some problems with the cartridges. When we are trying a catalyst, a heterogeneous catalyst with too little particle size, we are facing a high pressure, differential pressure. So with higher than 14 bar pressure drop, we cannot use the 100 bar maximum pressure ability of the cubes.
We have also solutions for these. We are sieving and picking the right particle size after the meshing. And the second option is to diluting the catalyst with the support material or with inert material to ease this very high pressure drop on the catalyst. Swelling is another problem. It comes basically with polymer bound catalyst. These polymer supports can swell when they are in contact with different solvents. So after we are using these, you can face a high pressure drop or even blockage at the end. Our solutions for these to fill the cartridge only half or third quarter of the volume of the catalyst, or excluding the not usable solvents for these reactions or catalyst types. Leaching is another different problem because the normal catalysts are just adsorbed on the surface. Leaching can happen during a reaction. First solution is to discontinue the production. This happened with platinum dioxide catalysts, which were not able and usable for flow chemistries. Okay, let's talk about the custom catalysts. It happens when the customer doesn't want to buy a commercial catalyst for our portfolio. We have two ways to fulfill their needs. We have a service, a custom catalyst filling for fee. We fill the catalyst here in Budapest. The user can use their catalyst with the safety datasheets, of course, and under a non-disclosure agreement, we have the ability to fill and test the cartridges and send them back to the user. There is no minimum price limit, and this service is also available just for only one cartridge. The second way is that in our portfolio there is a CatCart background closer instrument option. Users can buy these instruments, and with our help and training they can fill the cartridges by themselves with the catalyst they are having. Now we have time for questions and answers, and thank you for your kind attention.
Welcome everyone. This is the live Q&A session of the webinar. We are waiting for your questions. Until then, I like to show you the CatCarts in real life, how to change them in the instrument and how to put them inside a holder and the Phoenix flow reactor. So let me go to the next camera. First, coming closer. This is good. A little zooming. So these are the H-tube type CatCarts. This is a cross section of the CatCart side. Here the two ends are the sealings, and inside the catalyst filling. This is the longer 70mm one, and this is the shorter 30mm cartridge. This is a normal one, and this is what we modify for a micro CatCart. All right. The next is the MIDI cart. Here you can see the stainless steel closings and the 6 separators made of PTFE and the 5 separated catalyst zones inside. The next ones are the metal sealed cartridges. This is the smallest one, and this is one of the biggest. This is the 125mm, and this is the 250mm long 1-inch outer diameter cartridge. And this is a so-called CatCart holder for the Phoenix flow reactor, and here you can put the metal sealed cartridge inside, and using 4 of these aluminum holders you can put this inside the inner heating blocks of the Phoenix flow reactor. Changing the catalyst in the metal sealed cartridges is easy. You just have to loose the ends, and you can wash out your catalyst from the tube, fill it with your own and new catalyst, close it back again, and you can reuse the cartridge at least 5 times. So let's see if we have any questions. Okay, no questions yet. All right, I don't see any questions from the comment section. So if any question pop up in your mind later, you can write us an email to asthechemist@ThalesNano.com address, or you can find us on our webpage www.ThalesNano.com. I'd like to tell you about our next webinars. Next week on Wednesday and Friday, the HGenie and Phoenix connected system will be introduced through a webinar. Thank you again, and bye.